Hello everyone and welcome to your growing unit math test review. This will be a little bit longer of a test review because it's been such a long unit. We've been working on it since before winter break. So you may need to break it up into 2 nights. We ready? Let's get going. Like any test review, I will first read you the problem and then I'll ask you to pause it and do the work. And then after you're done, restart the video and you will see all the work done for you. So, first question. In Louisville, there has recently been a rapid, that means a very quick increase to the rise of the prairie dog population. In 2013, there were 500 prairie dogs and the population has continued to grow. Below is a predicted population chart for the future. So we look year 0, 2013, and we have 500 prairie dogs. Your job is two things, and they kind of go together. First, find the growth factor. You may want to start with B. So find the growth factor, and then use that to write an equation. Pause your recording now. Let's start by finding the growth factor. So I'm sure as you remember, we just take 2 numbers to find the growth factor on our chart, and what we do is that we work backwards. So I'm going to work right up right there. So whenever we work up, we divide. I will do 600 divided by 500, and my growth factor is 1.2. My growth factor is 1.2. Now, I can use that to write my equation. Y equals, my y-intercept is 500. This is an exponential equation, so 1.2 to the x power. That is how I write my equation and growth factor. Final questions in this problem. How many prairie dogs will be in Louisville in the year 2021? Pause it now. This problem has a little bit of a trick to it because you have to figure out where 2021 lies on the chart. So, year 0 is 2013, year 1 is 2014, 15, 16, all the way down. Year 6 is going to be 2019, 7 is going to be 2020, and finally year 8 is going to be 2021. That is the first half of this problem. Since I have to work up to year 8, I'm just going to take my last year, which the population of prairie dogs was 1,244. 1,244, and I'm just going to use my growth factor to get all the way up to year 8. So I'm going to times that by 1.2. That's year 6 times 1.2. That's year 7 times 1.2. That should be year 8. And obviously, we want to round it off because we can't have 0.6 of a prairie dog, at least alive. So my answer is about 2,150 prairie dogs in the year 2021. There is a similar type problem on the test, so if you have a question with this problem or any other we do, please come see me as soon as possible. Next problem. Mr. Hertz is in the school's brain bowl where he receives 300 points. I know it's covered up a little bit, but it's 300. 300 points for the first correct answer he gets in the brain bowl. After the first answer, he gets 50 points for every correct answer. So, your job right now is I would like you to make a table showing 1 through 6, if he got 6 answers correct, 1 through 6, and then make a graph for that table, please. So take a bit, but pause your recording. Go. All right, your table should look something like this. If he were to get 1 answer correct, Mr. Hertz, if he was going to get 1 answer correct, he would receive 300 points. 2, since he gets 50 points for each additional answer, it's 350. 3 is 400, and you'll work your way down. This is obviously very easy math if you know what you're doing. And 6, he'd work up to 550. For the graph, so you don't have to watch me draw the whole thing, I'm going to pause it now and make a graph. And there's the graph. The big thing about the graph is, I know it's a little messy and smushed, but you see how I have my axes labeled? This side is points, the other side is answers correct, and I'm just working up by 50s each time. It's a straight line. Last part of this problem is I would like for you to please, using your data, write an equation. Remember what kind of graph this is that'll help you write your equation. Pause it now. Writing the equation for this graph is a little bit more challenging than it looks. I actually think this is one of the more challenging problems on the test. So this is a linear equation, not an exponential equation. So here's how it is a linear equation. So here's how we're going to start. It's y equals mx plus b. So my y-intercept, again, where my graph starts is 300. Now, here's where it gets a little bit tricky, is my slope or my rise is 50. It goes up by 50 every single time. That's my slope and my rise. Now, my variable is, if I were just to times it by the number of correct answers, I would put x. So let's try that. If I was going to put in 2 correct answers, this one right here for 2, I would get 50 times 2, which would be 100, plus 300, which would be 400. So I put in 2, and I should get this, but the problem is I'm getting this right here. So I have to move it 1 up. The way to solve this is minus it by 1. So if I put in 2 again, 2 minus 1 is 1. 1 times 50 here. 2 minus 1 is 1. So this turns into 1. 50 times 1 is 50. Plus 300 is 350. I was able to get the right answer, and this will work for any of them. So this right here is my correct equation. If this doesn't make sense, I know it's a little bit challenging. Come see me. The next problem is a similar type of problem, but obviously it does have one major difference. So Richard participates in a different brain bowl with an alternate scoring method. This brain bowl gives 3 points for the first correct answer. The second correct answer gets you 9 points, and the third correct answer gets you 27 points. So again, your job is to make a table 1 through 5 and make a graph. Pause it, go. I hope that you notice the pattern when you're making your table. So 1 correct answer gives me 3 points. 2 gives me 9. 3 gives me 27. 4, so I'm just timesing it by 3 every single time. 4, excuse me, I'm not timesing it by 3. I'm bringing it to the next power. So this one is 3 to the first power. This one's 3 to the second power. This one is 3 to the third power. This one, number 4, is 3 to the fourth power, which gives me 81. And then my last one is 3 to the fifth power, which gives me 243. Again, I'm going to pause it so you don't have to watch me make my whole graph. I'm going to pause it now. Here's what my graph should look like. Again, pay close attention. Big hint, I have labeled my axes. This one, my numbers start low, they stay low for a while, and get big very quickly later in the game. That is an exponential graph. Final one, and I'm sure you know what it is. Write an equation for this now. My equation for this is pretty simple. Y equals, my base is 3. My base is 3, and then I just go to the x power, because this one is 3 to the first, 3 to the second, 3 to the third, all the way up. That's my equation. It's an exponential equation. That's my growth, and that is it. On the test, you'll have 2 similar problems to that. The next part of it is you have to analyze the 2 problems. So you'll be given a question, like look back at your last 2 problems and say how they are alike and how they are different. Please pause and do that. So on this test, just like any other test, TCAP, SATs, all the big ones, most people get marked wrong or they get half because they don't answer both problems. please, in this test and any others, answer both problems. So how they are alike. You could have said things like they were both in Brain Bowl. Or they both had increased amount of points with the more correct answers they got. Or something along those lines. Different. The biggest difference is your first graph was linear and your second graph was exponential. That is your biggest difference, obviously. And then you could have said something as well as the more points Richard got right in our second problem, he was able to get much more points at the end of the game rather than at the beginning of the game like in the first problem. So big thing is just make sure you answer the whole question. Not that hard of a question. Please don't miss any easy points on this one. The next piece of the test, you will be given problems. And each one of these are different problems, but all you have to do is say whether they are true or false. So it gives you the problem and actually gives you the answer, and you just say true or false. So I want you to go through each one of these. It'll take you a little bit, but go through each one of these. Pause your recording now and say whether they're true or false. For number 1, 7 to the 100th times 7 to the 10th. Obviously, I keep my base the same, but I do not times my exponents. I add them. This is false because it should be 7 to the 1/10. I add my exponents in multiplication problems. Number 2, 9 to the 0, anything to the 0 power, doesn't matter if it's million, a decimal, a fraction, anything to the 0 power does equal 1. That is true. Number 3, 8 to the 9th divided by 8 to the 3rd. Whenever I divide my bases, I subtract my exponents. 9 minus 3 is 6, so this should be 8 to the 6th, not 8 to the 3rd. This is false. Number 4. This one is a little tricky because I have 4 to the 5th and then I raise that answer to another 4th. So if I raise it again, I actually do multiply them. So since there's not on the same level, it's raised again, I do multiply. 4 times 5 is 20, so this is 4 to the 20th power. Negative exponents. As Mr. Baker went over in class, whenever you have an exponent, you actually, it will become a decimal for a negative exponent. So this one, to the negative 2 would be negative 0.25. It would not be 4, so this is false. Number 6 on this is a very long and complicated problem. I'm just going to give you the answer for now. It is true if you do not know why, because this one was off of your homework directly. If you do not know why, please come see me or look at your homework. Yeah. And the last one, my bases, my exponents are actually the same. So I keep my exponent the same. 3 times 4 is 12. 12 to the 5th. That answer is true. This is a big piece of your test. It's just true, false, but there is a lot of different type of problems on this. Please come see me if you need any help. Scientific notation. I know this is kind of a new concept worked on in math and science, but it stays the exact same. You had homework on it just recently. So again, scientific notation, don't worry about doing all the counting and all that other stuff on this one. I just times my bases together. So my base and my base, since it is a multiplication problem, I times my bases together. I have, let me clear this out, I have 2 times 1.5. That gives me 3, but it has to be a decimal for scientific notation. So I have 3.0 times 10 to the, this one it's third, this one it's fourth. In multiplication problems, I add my exponents times 10 to the 7th. That is my correct answer. You'll have a problem similar to this on your assessment. The last problem that we are going to do is the most complicated problem on the test. Make sure you know how to do this problem because there are very similar problems on the test. So, on grid 1, this is my grid 1. Grid 1. You need to sketch and label graphs of 2 to the x and 2.5 to the x power. So how you would do that is, if I had y equals 2 to the x, I'd have my x and I'd have my y. 2 to the x. So I just count down, probably go to 5 because that's what my graph goes to. But 2 to the first power. 2 to the first power is 2. 2 to the second power is 4. Put in my 3 for x, 2 to the third power. You could use your calculator or not. That is 8. And then you work all the way up, and then you graph it out. And that is one graph. Then you will do 2.5. You will have 2 lines on each graph. Then you will do the exact same thing on this one right here, 0.5. So make your table first and then graph it out. This will take you a while, but this isn't a very important problem. Please take the time to do that now. I'm not going to take the time to make each table for you on this and go through how to graph out each thing because I think we all know it. If not, come see me in person. I'll be having study sessions all week. So what this should look like, and I'm just going to skip right ahead. I pre-made the graphs for you, is my line in red will be 2.5. So this is 2.5 to the x, and then my line in black right here will be 2 to the x. So you should have something similar to that on yours. My line in blue right here will be 0.5 to the x, and my line in green will be 0.2 to the x. Should be pretty straightforward if you do your tables. Make sure to use a calculator on that one. Going back, after you make those, which are very time consuming, you will have to analyze your graphs. So on the first one, and this shouldn't be too bad, on grid 1, which is the faster growth, and then on grid 2, which is the faster decay, or decreasing the fastest rate of decrease. Answer those now, please. This one shouldn't be too bad. My fastest rate of growth is 2.5, or what's in the red, it's growing fastest, and my fastest decay in the green is 0.2, getting smaller the fastest. Both are inverse exponential graphs. That, my friends, is the review. I hope that was the most fun you've ever had. I know it was for me. Please let me know if you have any questions throughout the week, and good luck on the test.